As we solve these systems of linear equations, even by elimination, keep in mind the framework. You could have one solution if they're intersecting lines, no solution if they're parallel lines, and then infinitely many if they are coinciding lines. Now, to solve by elimination, we want them in standard form, or at least that order. The x term, then the y term, equals your constant. Okay, so the basic idea is that you can add things that have the same value. So here, 3x minus 6y has the same value as 18. So we're going to add 3x minus 6y to the left side of the first equation, and then 18 to the right side, because they have the same value. Now 3x and negative 3x is 0. It's eliminated. We don't have to write it. Some teachers may cross it out like that. 4y plus negative 6y is negative 2y. 12 plus 18 is 30. Now to solve for y, to get rid of multiplying by negative 2, divide by negative 2. And so y is negative 15. Now to find x, we can plug it back in. You can go to either equation. I'll go with the top one. We have negative 3 times x plus 4 times y, which is negative 15, equal to 12. Now we'll multiply. 4 times negative 15 is negative 60. From here, it's a two-step equation. To get rid of the minus 60, we'll add 60 to each side and get 72. And then to get rid of multiplying by negative 3, we'll divide by negative 3. And so we get x equal to negative 24. Put it together as an ordered pair, x, then y. Here we've got to translate this. First sentence says 4 times a number. I'm going to let x be the first number we mention. Minus 3 times a second number. I'm going to let y represent the second number. Is 12. And then the second sentence, 2 times the first number, 2x, added to 3 times the second number, 3y, is 6. Now notice we have opposite coefficients on the y, so we're ready to add these together. 4x and 2x is 6x. The y's are eliminated. Negative 3y plus positive 3y is 0. It's gone. 12 plus 6 is 18. To get rid of multiplying by 6, divide by 6. To find the y value, plug this back in. I'll go with the second equation this time. So I have 2 times x, which is 3, plus 3y equals 6. Multiply, you get 6. Now we'll subtract 6 from each side. We get 0. So 3y equals 0. And then to get rid of multiplying by 3, divide by 3 on each side. And so y is 0. Put it together as an ordered pair, x, then y. So our final answer is 3, 0. Here, if we add them just like they are, now don't write this down, but if we add them just like they are, we would get 8x minus y. So nothing would be eliminated, equal to, 46. But we want something to be eliminated when we multiply, or when we add the equations together. So we're going to multiply one of our equations by negative 1. The reason for that is because the x's have the same coefficient. We want them to have opposite coefficients. So we'll distribute this negative 1. We get negative 4x. Negative 1 times negative 3y is positive 3y. And then 18 times negative 1 is negative 18. Rewriting the top equation below it. Now we're ready to add our equations together. The x's this time are eliminated. We get 5y equals 10. To get rid of multiplying by 5, divide by 5, and so y is 2. Now we're going to take that value, plug it back in. I'll go with the top equation. So we got 4x plus 2 and then in parentheses, instead of the y, we're putting 2. So we have 4x plus 2 times 2 is 4. Two-step equation from here. To get rid of the plus 4, subtract 4. So we have 4x equals 24. And then to get rid of multiplying by 4, divide by 4 on each side. And so x is 6. Put it together as an ordered pair, x, then y. So our answer is 6, 2. Here we've got to also translate them. First sentence, sum of two numbers is 24. We don't know what those numbers are, so we'll let the first number be x, the second number be y. Sum means add. The difference of the numbers, difference means subtract, is 6. What are the numbers? We already have opposite coefficients on the y. 1y and negative 1y are opposites. Now when we add these together, 1x plus 1x is 2x. The y's are eliminated. And then we get 30 over there. To get rid of multiplying by 2, divide by 2, and so x is 15. I'm going to take that and plug it back in. I'll go with the top equation. We'll have 15 plus y equals 24. Subtract 15 from each side, and we get 9. So y is 9. So our ordered pair is 15, 9. These already have opposite coefficients on the x, so we're ready to add them together. Negative 4x plus positive 4x is 0, it's eliminated. Positive 5y plus negative 5y is 0, it's eliminated. If everything is eliminated on a side, write down the 0. On the right side, 20 plus negative 20 is 0. 0 equals 0, that's true. So these are coinciding lines. Our answer is infinitely many solutions. All the points on one are on the other. If we add these equations exactly like they are, nothing's eliminated, we would get 6x plus 2y. So we have the same coefficients, so we just need to multiply by negative 1. So distributing that negative 1, we get negative 3x minus y, 1y. And then 3 times negative 1 is negative 3. Now rewriting the top one below it. Now when we add our equations together, negative 3x plus positive 3x is 0, it's eliminated. Negative 1y plus positive 1y is 0, it's eliminated. So we write down 0 for that side. Negative 3 plus 7 is 4. 0 equal to 4 is false, so this is one that's no solution, or you could write empty set. So either that or this symbol. The set of solutions is empty.